everybody, Dr. Burns here. Let's take a look at Unit 2, and we're starting with Section 4.1, and we're getting into scatterplots. The purpose of Chapter 4 is to look at the relationship between two numerical variables. So that's really the key thing to remember, is that we're considering how two numerical variables are related to each other. And we're going to start by looking at scatterplots in this section. Make sure your cell phone is put away and you're listening to what I'm saying and not just writing things down from the closed captions, and you're ready to focus. So first of all, what is a scatterplot? Scatterplot really is just like it sounds. Here's a picture of one right here where we've got two numerical variables. So in this example, we're looking at floors, number of floors this way versus heights of buildings in meters this way. So we're looking at data points. How are two of these variables related? And the scatterplot shows all of the different data points in our sample. So let's be a little more formal about that. It's the primary tool for examining relationships between two numerical variables. And that's really the thing to remember, because later on we're going to look at categorical variables in a different way. But when we look at scatterplots, the variables have to be numerical. Each point in the scatterplot represents one data point. Okay? So let's go back to this example. What does the scatterplot tell you about the relationship between the number of floors in the buildings and their heights of the buildings? So you want to think about, as you read the graph from left to right, what is the trend? What is the relationship that you see? It looks to me like in this graph, as the number of floors goes up this way, the heights of the buildings also tend to go up. And there's some exceptions to that, but generally that's the trend. It's an upwards trend this way as you go from left to right. So what can we say? Let's write that down. So as the number of floors, number of floors increases, the heights, and I'm going to use the word tends to increase. Because, like I said, there's some exceptions to that. So you want to kind of give yourself that little bit of an out, but say tends to increase or seems to, or on average they increase. So when we talk about scatterplots, there's three features that we want to focus on. Similar to the last chapter, there were three things we focused on. We looked at a graph of numerical data. Same kind of idea. We're going to look at three things. We're going to look at the shape. So whether it's linear or not. There are other types of relationships with numerical variables where they're not linear, but we're not going to get into those in this class. So in this class, our main thing is it a linear correlation? The trend, so is it positive or negative or no trend? And the strength of the trend. How strong is that relationship? In some graphs, you'll see that the points are very, very close together, and other graphs you'll see that the points are very spread out, and that tells us about the strength. In the notes, I started with trend, so let's go to that. The trend of the scatterplot as you read from left to right. So let's see. So let's say the direction is what we mean by the trend. The direction of the scatterplot as you read from left to right. So in this last example, you kind of saw an upward trend. As we went from left to right this way, the dots tended to go up. So in that case, we would say that it's a positive trend, or that the line, it's going to be a line eventually, a regression line, because like I said, these have to be linear. But the relationship, we can say that it's increasing, an increasing trend, or a positive association. And by the way, association, relationship, correlation, those are all used interchangeably in this unit. So you'll hear me kind of bounce around, but it's literally a relationship between the two variables. If, on the other hand, the points were going down from left to right, that would be a decreasing trend or a negative association. And if there is neither a positive or negative tendency, in other words, if the points are just kind of all over the place with nothing definitive happening, then we could say that there is no trend. That is possible. Okay? The strength would be how close together or spread out those points are. So a scatter plot with, let's see, I think I meant to say small amount of scatter or vertical variation indicates a strong association. So the closer the points are together, in other words, the stronger the association. So if there's a small amount of scatter, a scatter plot with a large amount of scatter, or let's see, I need to change the phrasing here. So a scatter plot with small amount of scatter or vertical variation indicates a strong association. A scatter plot with a large amount of scatter or vertical variation. So in other words, if they're spread out more vertically, something like that, versus where they're like really close together, that would be a stronger trend. This would be a weaker trend down here. Indicates that we have a weak association. And we'll see plenty of examples of this. You'll get the hang of it. It's not too bad. And then finally, shape. And actually, I probably should have put this first in the notes, so I may make that edit in your notes, so just be aware of that. But shape is the first thing you want to look at. The scatter plot is either linear or it's not for our purposes. So scatter plots that cluster around a line model a linear trend. Anything that you can't sort of visualize that line with indicates something that's nonlinear. So not all data trends are linear. We'd model these data trends using a non-linear model rather than a line. And like I said, in our class, we're just going to stick to linear. So that's the main thing to worry about. So when you're writing the descriptions of these associations between the two numerical variables, these are the three things you always want to follow. You always want to talk about the shape. You want to talk about the trend. This is kind of the order I'd go in. Start by deciding if it's linear or not, because it's not linear, you don't proceed. It's either linear or it's not. The trend, whether it's positive or negative or no trend, and then finally the strength of that association. And then if you have any outliers, any observations that don't fit that general trend, you want to mention those in your description. Always use phrases, always use a phrase such as, I really like the phrase tends to, that tends to be the one I use the most. But you want to say a phrase that's like, on average, this is what's happening with the data. As the X variable increases, the Y variable appears to, or on average, or tends to increase as well, or decrease, or whatever. There's always exceptions, and not everything fits the data perfectly. So you want to be a little bit open-ended when you say these. And always point out any data points that appear to be outliers or not part of that general pattern, as I said here. Make sure you mention anything that might be a potential outlier. And we'll do plenty of practice with this in class tomorrow, so make sure you bring your notes with you.